welcome to this session of fluid inclusions in minerals. We have been discussing about the fluid inclusions, their optical properties or the way we see them under the microscope. We identify them, they are very distinct by virtue of the optical properties in terms of the, because they are fluid filled cavities, they will be having a sharp contrast to light within the solid mineral host, and depending on the assemblage in which the fluid inclusion is present. And we will continue our discussion from where we left in the last class. Just to recapitulate that, we will then when you see the inclusions under the microscope, typically an aqueous biphase inclusion will have the aqueous liquid will be a brighter part with a vapor at the anywhere within the inclusion, depending on the geometry of the inclusion. It could be at a corner, it could be at the just at the center or anywhere, and sometimes executing pseudo Brownian movement, and the dark rim around the bright central part of the vapor bubble is explainable the way we saw them. So, these are the aqueous biphase inclusions, where the inclusion is present in the form. So, we call it biphase because it is present as liquid and vapor, and it is dominantly water. Although we know that this water is not a pure water, in most of the cases it is charged with, or it has a dissolved total dissolved solid. That means the soluble salts, mostly chlorides, sometimes bicarbonate, carbonate, sulphate, and so on, of many of the cations like sodium, potassium, magnesium, calcium, iron, and many of the other cationic species. And this is what we see, that this one type of inclusion sometimes are pretty abundant, because of the fact that we have a water rich fluid in most of the cases. The dominant constituent of the fluid that we deal is water, and in many of the situations in the in crustal and in crustal conditions. So, that is why we see that these inclusions generally constitute a dominant number in any of the samples we study. Okay, so what are the other possibilities or other types of inclusions that we can see in inclusions, and we accordingly we classify them. So, this we have already seen, that is our aqueous biphase inclusion with liquid plus vapor. Now, situation could be, so which we will be explaining in terms of very simple phase diagram, which we will keep on revisiting for our understanding. The other possibility is that an inclusion we could see that it could be an aqueous liquid, there could be another liquid which is shown in the light gray color here, and the within that is another is a brighter part. So, sometimes we can identify them, and through their phase properties we could confirm them that this actually is an inclusion where the sketch of the inclusion is shown here. It is a polyphase inclusion in the sense that it has two liquid and one vapor. So, an aqueous liquid which is labeled as LH2O, and an aqueous as a carbonic liquid is LCO2. This carbonic liquid could sometimes be mixed with a little bit of methane, not all the time pure carbon dioxide, and a carbonic vapor. So, because and then another type of inclusion also, which call them as polyphase inclusion, they contain, in addition to the liquid which is shown here in light blue, and liquid and the vapor, they can have either one or more than one solids present in them. They are well identifiable because of the fact that we are already, they are pretty thin. We are seeing them in micron thickness, where the as our any other solid can be identified in a thin section, they can always be identified, because they do also have contrasting refractive index compared to the liquid medium in which they are dispersed. And the just as a sketch, it is shown that a inclusion can have many, either one or more than one solid crystal. The one which is like a cubic shape is a probable mineral which is halite. An inclusion, a natural inclusion in quartz example which is shown here, we could see a very nice cubic crystal sitting within the inclusion cavity beside the vapor, and this inclusion is in a quartz taken from a sample courtesy Kingsley Börjlenson's web page, and this we call as a polyphase inclusion because there is a liquid, there is a vapor and there is a solid, and there could be more than one solid sometimes if the original fluid, the parent fluid in a very concentrated brine what we say, and which becomes saturated with respect to many mineral phases when the temperature is decreased. So, there could be a prismatic grain like this, it could be there dispersed in this liquid which could be either a gypsum or an anhydrite. There could be the rhomb shaped solid is representing either could be a calcite. The yellow circular one could be sylvite, that is potassium chloride, and there is sometimes also there are some sulphide which is showing as a chalcopyrite small micron scale chalcopyrite grain which is within the inclusion cavity. So, this is a means it is not necessarily that polyphase inclusions will always have more than one, dominantly will have one, but under certain extreme cases that we will be discussing later on, there can be more than one such solid crystals within the inclusion cavity, and in many of the situations we also see that the inclusion is just occurring as a monophase without anything within any content any other phase in that. We tentatively classify them, categorize them as monophase inclusion, and sometimes they turn out or they give some information later on, but when and these are the situations that we see are basically corresponding to the room temperature condition. So, when we basically subject this particular inclusion which is monophase at room temperature to different temperature conditions, we might actually know what it is, and many of the times sometimes we are also not able to know. A phenomena which is called beta stability, which we will discuss later. The example of a polyphase inclusion with two liquid, that is an aqueous liquid, here the carbonic liquid and the carbonic vapor. This inclusion as you could see the micron bar, it is a very large inclusion measuring more than 100 micron in its maximum dimension, is a more or less regular shaped elliptical kind of shape inclusion, and in which we could see this is a very good example of this inclusion is occurring in a topaz, and there are several such inclusions like this shown here in the same topaz grain, where you could see that as against the liquid water and the water vapor, the case which we just saw before where it formed a very dark rim around the vapor. In case of carbonic liquid and carbonic vapor, because of the low or the less of the contrast in the Ri of a carbonic vapor and a liquid, this rim, the dark rim is pretty thin, separating the liquid carbon dioxide and the vapor carbon dioxide. Similarly, the boundary between the two liquids, the aqueous liquid and carbonic liquid, is also pretty distinct and can be very well observable. So, these are examples of some of the polyphase inclusion containing a single gypsum crystal, and here is an inclusion containing a single calcite crystal. They are taken from the mineralized quartz body in the Malanskan copper deposit. So, although we will be discussing and correlating them to the phase relations in simple systems like water or water plus salt, one thing we must it would be worthwhile to tell now that the solid phases that they are occurring here, or even in the previous case like this, these solid these crystals which we find in the inclusion cavities, either they mostly it happens in aqueous inclusions. The polyphase inclusions bearing daughter minerals in majority of the cases or in almost all the cases happen in aqueous inclusion, because of the very simple reason that when there is appreciable amount of non electrolyte dissolved in water, the solubility of the salts decrease, which we will see them in greater details when we look at the phase diagrams. But for the time being, it would be worthwhile to just remind that the daughter crystals which we are seeing them in the inclusion cavity, they are the ones which are likely to have been precipitated from the fluid after the fluid was encapsulated within the solid host of the mineral, solid mineral host. But at times it may also so happen that this particular crystal actually did not crystallize or did not precipitate from the fluid that was encapsulated in the host mineral, but actually was captured as it is along with the fluid, along with the liquid when during the process of entrapment. So, it could be that this solid crystal was accidentally entrapped within the inclusion cavity. We will discuss a little bit more about them later. So, here the whole idea is just to get yourself acquainted with certain unusual situations where we see that we have already seen how the inclusions look like. Some of the aqueous biphase inclusions, aqueous polyphase inclusions, dominantly the aqueous inclusion, or even the aqueous carbonic inclusions. These are this photograph is taken from some of the migmatitic gneiss from Eastern Ghats belt, and they in fact can be occurring anywhere from any sample that you pick up from any of the geological terrain. You see cavities which almost look like just dark cavities. I mean, there is nothing as if they are just so sometimes they are described as just empty cavity, because when we will be again seeing them later that if we subject them to some microthermometric experiments, they do not respond, or they do they do not come out very clearly indicating their compositions. So, it is possible that they could possibly have been cavities, or the content have been totally lost from them, but in some of the cases they do represent that they are essentially inclusions which are just vapor, they do contain just vapor, and in majority of the cases they turn out to be containing vapor of carbon dioxide. And why it is so, we will be explaining through the appropriate diagram, phase diagram, when we see for these particular systems. We will have a very short tour to just bring home to you that what are the diversities in the shapes and sizes of these inclusions. To be in general, we see that, and when we see them in quartz, as the majority of the host mineral, when we see them in quartz or in any other host mineral for that matter, we can get an idea about what are the diverse sizes and shapes in which we can see them. This is an example of aqueous inclusions in quartz, this particular one. This is taken from the Malanskhand quartz ore body, and we could see that what generally we mean by the inclusions, which are the part of the random 3-dimensional network, not following any particular trail or particular linear array of these inclusions. They could be just, and we could see they can have an idea about the sizes, and while looking at the sizes of these inclusions, we also can have it in our mind to just to see that what kind of a proportion that we could see of this vapor when we take at the liquid and liquid plus vapor ratio, even though we know that we are not able to see the third dimension. So, knowing the exact proportion of the vapor in this particular inclusion would be not be very accurate, because we do not know the third dimension. So, the sizes and the shapes of the inclusion, which is more characteristic, that the inclusions can actually attain any shape. So, the question remains that whether the shape, the various shapes that we see the inclusions, whether it is a characteristic which is inherent or represent the very primary characteristic, or the various shapes could also result because of later modification of the inclusion cavities shape because of any other re-equilibration process or any other perturbations later on. And that has been one of the major topics of research in the later part. In the recent there have been many such experiments which are being done on them. We will discuss them in due course of time, but before that it should be worthwhile to just see the various types of possibilities. We could see the wide diversity of the shapes and size, and also the phase proportion. Here this is a inclusion assemblage. Generally we put in the term, I will come to this particular word as inclusion assemblage when we discuss more about fluid inclusion petrography. So we see these two inclusions, one here and one there, and this particular one which is a little out of focus also is an aqueous carbonic inclusion, where this this cavity, this particular part here is the carbonic liquid, within that having a carbonic vapor, and the one which is here is also an aqueous carbonic inclusion, but the difference between them is that one in the first case it has the aqueous part is much more dominant, even though we do not know the third dimension, but still we can make out that in this case the aqueous part is far more dominant than the aqueous part over here, or the reverse is that this particular inclusion has a far more proportion of carbonic liquid, the carbon dioxide carbonic component compared to this. And here also even these are two different photographs, but they are from very nearby inclusions. The one which is out of focus over here is brought to focus here, and the one which is on focus here is out of focus here. And so you could make out that the difference in the proportion of the carbonic component in the same aqueous carbonic inclusions. These are to be noted, and we can discuss them when we go back to their phase diagram and the entrapment conditions and a bit of details on them. This also here this is an example of a fluid inclusion, aqueous inclusion, and within which you could see a very clear crystal, prismatic crystal which is present there, and here again it is an aqueous carbonic inclusion with a. So we can see that the kind of various kind of shapes that these inclusions represent. They could be, sometimes could be when we take the 2 dimension, there could be circular, there could be elliptical, and sometimes they are just too very irregular in their shape, which will so as we were discussing that this is a section of the, this is a wafer taken at a much lower magnification, and we can see the part of the quartz over here, and we could see, as we were just discussing, that when they grow in or when they form from the fluid phase, the inclusions within them could be just randomly distributed. Very quite often or quite on certain instances we see that there is a difference in the inclusion population compared to the central part of the grain compared to the periphery. It also happens, and we will discuss them in due course. And this part which has been just magnified over here, and even we could see that within the same trail there are so many diverse types of shapes of inclusions that are present. This also is a sample from the Ramagiri Pennacha schist belt, auriferous schist belt, which has been taken here, and we could see that in the rock, which essentially is a schistose rocks, within that this particular quartz, which represents a very incipient vein that is formed within the shear plane within this schistose rock, and a magnified view of particular part of this quartz is showing the distribution of the inclusions, the aqueous biphase inclusions, which are far more diverse in their shapes and sizes. Now this is an example again from the same Ramagiri Pennacha area to show the quartz aggregate of the quartz, and there are many such quartz grains which are present here. We could see the transgranular hill cracks as well as the clusters, and also same the grains of quartz with for example, this particular grain is having a population differential population of the inclusions in the core compared to the periphery, and the same is the situation here. And when we magnify this part, we see the inclusion population with diverse sizes and shapes. These are very interesting. Here there is a these inclusions have been taken from the from several very different generations of pegmatitic rocks from the Eastern Ghats Mobile Belt. We could see these are aqueous inclusions, and within that we see that these inclusions sometimes take very characteristic shapes like that of a this kind of a curved or hook kind of a shape in population of other ones. And the extreme case you could see here that even the one which is been focused here is an aqueous inclusion which has taken the shape of almost like a ring, or we call it an annular kind of a shape. These the probable reasons for these inclusions attaining such kind of a shape we will discuss. And we see the same kind of a situation. These are inclusions which are little regular in shape, almost the shape of bullets, and the one which is an aqueous carbonic inclusion, which is sometimes we describe them as tubular or elongated kind of inclusions, and the size we can measure. This is a inclusion which is almost measuring more than 20 microns in its maximum dimension, and similar this is also an area where these inclusions are all part of the random 3-dimensional network. They are not aligned on any heel crack, but you could see the characteristic shape of these inclusions, and in all these the host is quartz. And the one which I just showed before, some inclusions which almost look like dark and sometimes interpreted as cavities or empty or the vacant spaces, or just as if the content has been lost. But in other instances we see that in majority of the cases that they are actually vapor rich inclusions, and they also do represent different types of shapes. So what generally it emerges that inclusions which are on the heel cracks, on the inclusions which formed during the process of the healing of the crack in the host mineral on fractures which are created later, some such inclusions have a tendency to change their shape or become more kind of whatever the shape ranges we have seen, compared to the ones which actually are present in the part of the random 3-dimensional network, and more so the smaller the inclusions, their tendency to retain their regular shape is more than the inclusions which are larger. So just to put it in a quantitative term, we know that the inclusions can range in sizes from even because we are seeing them under microscope where the magnification go to 400, 500 or 600 at the most, and the visibility range can start from like almost 1 micron, and we see such tiny microns inclusions, and the maximum can go to 100, 200 microns, some of the photographs of the aqueous carbonic inclusions that we saw here. Well, there are some examples of the inclusions in hosts other than quartz. This has been taken from the gabbro in the alkaline complex in Koraput. We could see the inclusions in garnet, and this is a magnified view of that. These are all carbonic inclusions of similar kind of size ranges, and this is just for example that how these inclusions, in a way it may not be possible to really distinguish from the photograph unless it is told that which is the host mineral from which the mineral has been, or the inclusions has been picked up. And it is also true that when we see them under higher magnification, in a reasonably moderately crystalline coarse the grain size of the host mineral, we would not be able to see many grains at the same time until and unless we look at them at a lower magnification and then see the distribution of these transgranular cracks, the heel cracks, or the intragranular cracks, or the distribution or the population of the inclusions, and then only when we look at the inclusions to examine them to know the phase proportions or the content in them, it has to be done in a higher magnification at which we cannot see many grains at the same time. Sometimes, so this is again the magnified view of fluid inclusions in garnet, the same host from the same rock assemblage, where we could see the inclusions have attained all such possible shapes, such irregular shapes, mimicking almost like they become just very irregular. We can't describe them as to what this shape are, but they are just very irregular. And this is an example of this same inclusion trails. This is also a trail which is magnified. Here, as we saw before, the interior of the grain, the smaller inclusions were almost of very regular shape, whereas in the inclusions which are present in the heel cracks, they are of many different shapes compared to what we possibly can call as a regular shape. And here is an example of a garnet and Klein pyroxene in a gabbro, and where we could see the transgranular cracks traversing between the Klein pyroxene and garnet. So this definitely indicates that this particular fluid was a later fluid during the compared to the stage at which this garnet developed. And if we can somehow establish the time relationship and we can look at the inclusion characteristics, then we definitely can tell something about the metamorphic evolution of this particular rock. And this is just for an example. This is an inclusion trail in a pyroxene from the same complex, this Koraput alkaline complex. Just to bring this fact to your knowledge that we can see inclusions in almost any mineral, as I told that, and these are some of the very unusual and rather very interesting situations. This photograph has been taken from the book of Craig and Vaughan, the ore microscopy and ore petrography, where if we could see this microns bar, which is 200 micron, then this is entirely a aqueous biphase inclusion in cassiterite. As you stated before, the minerals like cassiterite, wolframite are also amenable to fluid inclusion studies, and they are regularly being studied for fluid inclusions. And here one thing which is very interesting, that this particular inclusion, it has got two vapor bubbles, this elongated vapor bubbles, because if we as common sense would say that if there is an inclusion cavity, and this is liquid, there can be only one vapor possible, because vapors are all miscible in all proportions. So it's not possible, or it's not theoretically getting more than one vapor bubble in the same inclusion should be a case which would be considered as unusual. And here the inclusion geometry itself is very characteristic in the cassiterite, and because of this flat geometry of this inclusion, these two vapor bubble even couldn't also coalesce to form one. So quickly we could just have a look on the different possible types of shapes of the inclusion that we can see. These inclusions have been taken from anhydrite, from some of the area in the South Delhi fold belt. What is observable here is, even in this diagram, these inclusions in anhydrite, even if they are present in heel cracks or present in the part of the random 3-dimensional network here, they do tend to attain a very regular, almost mimicking a crystal. So, that is why the word negative crystal has been used for them. There is nothing like cannot be a negative crystal, but when an inclusion cavity is mimicking a regular crystal shape or the crystal faces, or what basically is looking at as if it is mimicking the crystal system of the host mineral. So, that is they are called as the negative crystal, which is very often used in literature. And this is also, we could see here the same anhydrite, where some very interesting aqueous biphase inclusions mimicking the geometry of the host crystal are going by what they are called in literature as negative crystal shaped inclusions. You could see on all, just but one, leaving aside only one, which is a flattened geometry inclusion where the vapor bubble is not even truly circular. This is an example of inclusion in cassiterite, tubular inclusion. This is an example of inclusion in sphalerite, and this is again still very interesting. This is an example of inclusion in halite, the sodium chloride, and this photograph has been taken from this reference which is cited here, and these authors were essentially investigating the Permian paleoclimate, and they took the evaporite, the salt from the sodium chloride crystal from the evaporite bed, and they were trying to understand the characteristics of the fluid, the Permian paleoclimate. And you see these inclusions also, they are basically mimicking the crystal structure of sodium chloride, which is cubic, as we all know. So, and even though the distribution of the crystal over here in terms of size, that there is a wide range in the variation of the size if we look at the micron bar, but most of them, each of them do have something which you call them the negative crystal. So, it cannot be exhaustive description of the all possible sizes and shapes that is possible in fluid inclusions, but some of them which have been presented here would possibly give you an idea as to how varied the inclusions, fluid inclusion populations can be, irrespective of what their compositional characteristics, whether they are aqueous biphase or whether they are carbon dioxide liquid bearing or polyphase inclusions bearing crystals. They do display a wide variation in their sizes and shapes, and we can ask such basic questions: does size of the inclusion have any relationship with proportion of the vapor by vapor plus liquid? Is there any relationship between size and time relationship of the entrapment? So, we always look for the relationship, trying to categorize them. So, we will address these issues, ask these to try to answer these questions in the next lecture. So, we will continue discussing about these fluid inclusions and discuss something about so come to the very important aspects of categorizing them, doing the petrography, and then go to the experiments, microthermometric experiments, and continue with the further and the lectures to follow. Thank you.